everyone, my name is Christine Dibson. Let's talk about the tectonic plates and plate boundaries. The Earth's outer shell, the lattice-sphere, consisting of the crust and the upper mantle, is divided into a patchwork of large tectonic plates that move slowly relatively to each other. It's either convergent boundaries, divergent boundary, or transform boundary. So, there are 7 major plates and many minor plates. Varying between 0 to 100 millimeters per year, the movement of a plate is driven by convection in the underlying hot and viscous mantle. Earthquakes, volcanic activities, mountain building, and oceanic trench formation occurs along plate boundaries in zones that may be anything from a few kilometers to a few hundred kilometers wide. So there are 3 main types of plate boundaries. First, we're going to tackle about the convergent boundaries, in which the two plates, either it is continental or oceanic crust to oceanic crust, or continental crust to continental crust. So, subduction zone occurs when one or both of the tectonic plates are composed of oceanic crust. The denser plate is subducted underneath less dense plate. The plate being forced under is eventually melted and destroyed. For oceanic crust, let's say for example, this is the oceanic crust, and this is the another oceanic crust. So when they collide, island arcs and oceanic trenches occurs. Zones of the active seafloor spreading can also occur behind the island arc, known as the back arc basins, and these are often associated with submarine volcanoes. Now, the other example is when oceanic crust meets the continental crust. The denser plate, which is the oceanic plate, is subducted, often forming a new mountain range to a continent. The Andes is the example of this type of collision. The third one is when the continental crust meets the continental crust. Both continental crusts are too light to subduct to a continent-to-continent collision occurs, creating especially large mountain ranges. And one of the example of this continental crust, one of these example is that the Himalayas island. The second boundary is the divergent boundaries, in which two plates are moving apart like this. So the space created can also fill with a new crustal material sourced from molten magma that forms below. Divergent boundary can form within continents but will eventually open up and become oceanic basin. Now, there are 2 examples or main characteristics of divergent boundaries. It's either happening on the land or under the sea. Now let's talk about on the land. Divergent boundaries within continents initially produce reefs and produce reef valleys especially. Second is the under the sea. The most active divergent boundaries are between oceanic plates are often called mid-ocean ridges. The third boundary is the transform boundaries, in which the two plates slide past each other like this, vertically, not horizontally, unlike the convergent and divergent boundaries like that. The relative motion of the plates is vertically passing through each other. They can occur underwater or on the land, and crust is neither destroyed nor created. Because of friction, the plates cannot simply glide past each other, rather stress builds up in the both plates and when extend to the thrust folds of the rocks, the energy is released that causes the earthquake. Now, let's talk about the plate the plate let's talk about the mechanism of plate tectonics. First, we have mid-ocean ridges. The mid-ocean ridges rise about 300 meters from the ocean floor and are more than 2,000 kilometers wide, surpassing the Himalayas in size. The mapping of the seafloor also revealed that these huge underwater mountain ridges have a deep trench which bisect the length of the ridges and in place of more than 2,000 meters deep. That's it. And the next one is the geomagnetic anomalies. Occasionally, at random intervals, the Earth's magnetic field reverses. New rock form from magma records in the orientation of Earth's magnetic field at the time of magma cools. A study of the seafloor with magnetometers reveals stripes of altering magnetization parallel to the mid-ridges. This is the evidence for continuous formation of new rock at the ridges. As more rock forms, older rock is pushed farther away from the ridge, producing symmetrical stripes to each other of the ridge in the ridge. So the third one is the deep sea trenches. The deepest water are found in oceanic trenches, which plunge as deep as 35,000 feet below the ocean surface. These trenches are usually long and narrow and run parallel and near to the ocean margins. They are often associated with the parallel to a large continental mountain ridges. So, the fourth one is the island arcs. Chains of the islands are found through the ocean and especially in the western Pacific margins. The island arc is caused by the two continental crusts colliding each other. That's it. That's it. So, thank you everyone for listening and watching. Thank you. God bless.